So I've described internal forces, but how can you see them? Do you need special X-ray goggles to see these forces that are inside or internal to a member? Well, obviously not, and that's the point of this chapter. You're going to learn how to see or calculate the internal forces on two-dimensional members. Here's the process for determining internal forces in pictures. First, you solve this problem to get these reactions. Second, after you have this reaction, and you know the spot where you want to get the internal forces, let's say point B, which is just to the left of the 6 kilonewton load, you do a ninja slice, then you close the diagram, close the loop so you can make a free body diagram, and here's your free body diagram. So you can see what we've done here is I've drawn everything inside the loop, and the key thing is that you need to draw in the things you cut. And so you always put in, for a two-dimensional problem, an axial force, a shear force, and a moment. And those are three things. You have three equations. You could solve for those three internal forces using statics. And those of you who rather have a list or a procedure rather than pictures, here's what you do. You solve for the reactions. You slice where you want to find the internal forces. You close the loop. And also, I didn't write it down here. And you draw everything in the loop. And then you cut, and then you draw in what you cut. The moment, shear, and axial. And finally, you use statics to solve for M, V, and N. This is really the same as the method of section for trusses, except we're doing it for internal forces. Okay, so whenever you slice a beam, you have two choices. You can close to this side, or you can close to the other side. It really doesn't matter. You get the same answer either way. So what you do is you look for which side is the least complicated, or which side is the simplest to solve. And the reason it doesn't matter is that you will have the same internal forces on either side, but notice that they're equal and opposite. For example, you see here on the left piece that shear is going down, but on this one, the shear is going up. On the left piece, the axial is going to the right, and on the right piece, the axial is going to the left. And on the left side, the moment is counterclockwise, and on the right side, the moment is clockwise. They're equal and opposite. There must be some sort of sign convention for this. There is, and it's complicated. The reason the sign convention is complicated, it depends on which side of the cut you are. These are all positive, shown in the picture above, and it's kind of weird. So what I'm going to do to show you the positive sign convention is I'm going to draw a piece like this, and I'm going to draw shear, axial, and moment on one side, and I'm going to draw shear, axial, moment on the other side, and these are all positive. I'll explain them in a little bit. But what's confusing, you need to see that this one is this one, because it's acting on the left end of the member that's been cut, and this one is that one because they are acting on the right end of a member that's been cut. Now let me explain each of these in turn, why they're positive. Here's the axial sign convention. If you have forces that are pulling or in tension, this is positive. Next, I'm going to talk about the moment sign convention. If you have moments that go like this or like this, these are positive. So if you have clockwise on the left end cut or counterclockwise on the right end cut, those are positive. And the way I remember this is that if you take a ruler and you bend it like this, Okay, you put those moments on it. You can try get a flexible ruler and do that with your hands. It'll flex like that. And that kind of looks like a smile, see? And smiles are positive. I know it's corny, but that's the best way to remember that. The hard one for me to remember is sheer. And I don't have a smiley is positive. I don't know what to do, but this is positive sheer. This one I've just memorized. Up on the left side is positive, down on the right side is positive. So this is positive. So there you go. This is the sign convention for axial, the sign convention for moment, and the sign convention for shear.